Welcome to astronomy. So we're in Module 1A, the first part of Module 1. 1A is the backyard astronomy. And in this first part, so it's Module 1A.1, a little bit of introduction to astronomy. And we're going to talk about what you easily observe in the sky without needing a telescope. So we just need to start with an overview of astronomy itself and the whole sky in general. First of all, when you go out and look at the sky at night, every star you see is in our galaxy. Basically, it's true that every star in the universe is a part of a galaxy. Galaxies are collections of stars, and in the intergalactic medium, there's not much at all. In our own galaxy, the Milky Way galaxy, there's about 200 billion stars. When we say the universe, keep in mind that's everything. There could be multiple universes, but we won't be talking about that. The solar system is the sun system. The sun and everything that orbits it. That would include planets and asteroids. So we've got our 8 planets, and our old friend Pluto, who used to be categorized as a planet. Don't feel bad, Pluto's very happy being a dwarf planet. Our solar system does have a star in it, because the sun is a star. It's important for you to know the order of the planets. It's just important for you if you don't already know it. So learn some way to do it. You could just memorize it. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. But usually we'll take the first letter of each planet and make a nice sentence like, "My very elegant mother just served us nothing." It used to be, "My very elegant mother just served us 9 pizzas," but without Pluto, turns out we got served nothing. So what's in the sky that you can see without a telescope? Well, there's of course the sun, but let's look at night. There are planets, Mercury and Venus, and you can observe they are always near the sun. You will never find them far from the sun. Once the sun sets, they will be setting soon if they're up, or if they're in the sky, then in the morning sky, then the sun is about to rise. Only seen near the sun. Venus has a maximum distance when it's at greatest elongation away from the sun. It might not set until 9 o'clock at night. You'll also notice the planets are only in certain constellations, a band of constellations across the sky. This is called the zodiac, the zodiac that you're familiar with from astrology. The sun and the planets move across the stars, and they move eastward. You don't notice this. All you know is that the sun rises and sets. But if you could compare it to its position compared to the stars behind it, it turns out it moves eastward. And so do the planets, except when the planets are going backwards, except when they're undergoing retrograde motion. Turns out that retrograde motion, we only see it near opposition, which means when the sun is on one side of the sky and the planet's on the other. So if the planet rises at sunset, then it's likely it could be undergoing retrograde motion. This takes days. You won't notice it on one night. We need to talk about the ecliptic. Very important concept. It's the sun's path across the stars. We'll be going over this again in the seasons module, but wanted to mention it here that the sun moves across the stars. Draw a line to follow that repeating path that it repeats every year, and that is called the ecliptic. The sun's motion is not the sun itself moving. We're getting a different view as Earth is orbiting around the sun. On this star chart, you can see the ecliptic. Notice you can see the horizon too, and that the sky is a little bit warped to try and get that two-dimensional sky onto the smaller screen here. The ecliptic is the path of the sun, and if you were going to look for planets, that might be where you would look. And if you look carefully on this star chart, you will see Jupiter and Saturn lying right against the ecliptic. This is our view if you were looking towards the south, and from the northern hemisphere, you would only see the ecliptic towards the south in the southern sky, for the very same reason why you will only see the sun towards the south from the northern hemisphere. If you could see the ecliptic drawn across the night sky and see the planets near it, you would also notice that the moon moves along there. This is no coincidence. It's that our solar system is very flat, and that's why we only see the planets along the same direction that you can sometimes see the sun. The sun and the moon moved eastward compared to the stars, as do the planets, but sometimes the planets go backwards. That's what we call the retrograde motion. So they're moving eastward, but then something happens, which I'm not giving away right now, and they start moving backwards. The only clue you've had is that it occurs only when the planet's in opposition. Here you can see an animation of the night sky. The little dots are planets. There's the sun moving across the sky, and every month the moon flips across there. So you can see how fast motion this is, and that this whole animation is more than a year. Look at Jupiter slowing down there and starting to go the wrong direction. Notice the other planet also going the wrong direction. So these planets are right now undergoing retrograde motion, and now they're on their way. And the sun, which was on the opposite side of the sky as the planets, here it is now as we're moving so that the sun is getting close to the planets that we were looking at. Now, did you see that other planet go retrograde? Now here comes the sun with the Jupiter and Venus and Mercury orbiting around it, going by. So take a look at this image. This is a time image, and it has a planet that was undergoing retrograde motion, and each of these dots is a day apart. And you can see that it takes quite some time. It's not like one night or 1 week that you could see that retrograde motion. And in the background there's some other object that you can see, one dot of that fainter object for this. So what do you think that is? I'll try and reveal that answer in a later slide, but think about what that background object might be. The North Star, Polaris, very special star because it is always in the same place in the sky. The stars go around Polaris as the Earth is rotating. The rising-setting motion that you see towards the western and east, rising in the east and setting in the west, that motion is different in the north. And in the north, the stars circle around Polaris. And some of those, as you can see from this time-lapse picture, never set. Those stars are called circumpolar stars. What about our sun? Is it circumpolar? No, if circumpolar means it's either up or it's down, the sun is not circumpolar. Except for maybe this time of year in northern part of Alaska, because it actually might not set, the midnight sun effect. Well, what about zodiac constellations? Which of them are circumpolar? Well, how would you know? The zodiac constellations, those are the ones the sun goes through. So if the sun is in a zodiac constellation, well, at our latitude, it would have to set. The sun always sets. So at our latitude, there are no circumpolar constellations. I should say there's no circumpolar zodiac constellations. So a day is the amount of time it takes for Earth to rotate on its axis. But it's a little bit confusing, actually. Do you mean a day for when the sun comes back to the same place? Well, yep, that's what we mean, a day. But if you really meant the Earth rotates once on its axis, didn't you mean compared to the background stars? So these are two different concepts. The solar day where the sun returns to the same place, and a sidereal day when the stars return to the same place. Here's a diagram that's sort of complicated that tries to illustrate this. The little dotted lines there are just showing you, are just trying to say these words correspond with this location. So ignore those. Look at the solar day. Solar day from the Earth's perspective is when the sun is overhead till the sun is overhead for the same person on Earth. But a sidereal day, a star is overhead to the same star being overhead, and those two horizontally pointing positions, they're pointing to a distant star. Now the distant star is really distant, so those two arrows are parallel and they both point at the same thing because it's so far away. So same star to same star, that is a sidereal day, and you can see that it will come back to that, do one full sidereal day before you've completed one full solar day. So the sidereal day is 4 minutes shorter. By this sketch, which is totally not to scale, it looks like it'd be hours shorter, but really just 4 minutes shorter. What that means is the stars rise 4 minutes earlier every day compared to the sun. It also means they set 4 minutes earlier every day compared to the sun. You know the sun rises and sets due to the rotation of the Earth. Well, guess why the moon rises and sets? Yep, rotation of the Earth. And the stars move as well, and they rise and set or move around Polaris in circumpolar motion, all because Earth is rotating on its axis. Now if somebody asks you, hey, where are the stars in the daytime? Are they under the Earth? You can say, don't be silly. The stars are out there. In the daytime there's stars out there behind the sky, but the sky is too bright to see them because of the scattered sunlight. So could ancient people recognize planets? Truth is, they look like stars. However, without a telescope, there are a couple of clues. One is they twinkle less. They tend to be a brighter star and they twinkle less, and that's because they have an actual angular size to them that evens out the twinkling, whereas the stars are so far away. Even though they're bigger, they are tiny points, and so they twinkle quite readily. Planets don't twinkle quite as much. The planets might be brighter, but not always, than the stars. So that's not a for sure thing that a bright star is a planet, although it could be. But the main thing that ancient people would recognize is that planets move compared to the stars. The stars retain their same patterns all the time. The stars are so far away from our sun that the patterns that we see are completely constant. The stars are actually moving, but because they're so far away, the motions don't mess up the patterns. It would take hundreds of years for anything to change. If you wanted to see the constellations change, you would have to go so far away from Earth that you basically have to pass up some other stars. You can go anywhere in our solar system and those patterns will look the same. So would the constellations still have the same pattern if seen from Pluto? Yeah, and it's not because Pluto is in the same plane as all the planets. It's just that Pluto and Earth and the Sun are basically in the same place compared to all the other stars. And so the patterns that we see of the other stars would be the same, whether it's here or anywhere in our solar system. Try doing this. Get out a pencil and paper, sketch the Earth and the Sun, have the North Pole of the Earth right above at the top of your picture, well, okay, in the center. So you're viewing Earth from the top. Show Earth's rotation with an arrow, and then see if you can figure out, if you have Earth and the Sun, where noon, midnight, and sunrise are. And then where would Mercury be if you could see it in the evening? You can see Mercury from two positions on Earth, morning and evening. near midnight, you would not be able to see it. And then show that Mercury will always be seen near the Sun. So see if you can do that, and then view the video on the next slide where I do the same thing.
Sometimes Venus is a beautiful evening star, brightest thing in the sky. Okay, it's not really a star, but it is amazingly bright sometimes. And then sometimes you don't see it in the evening at all, but maybe you see it in the morning as a morning star. And sometimes it's in front of or behind the sun and you can't even see it. Well, if you see it as an evening star or a morning star, it depends on where Venus is in its orbit around the sun. So I have sketched here Venus orbit around the sun, and then over here is Earth. It's all not to scale. So Venus is somewhere around this orbit here. If you're on Earth and you see Venus as an evening star, then it's after sunset. Sunset is over on this side of the Earth here. And so if you're seeing it after sunset, you are over here somewhere, and you're not going to be able to see through Earth and see it if it's over here. So if you see Venus as an evening star and you're here, you must be seeing it over here. So if Venus is an evening star, it will be over on one particular side. It has to be over here if it is an evening star. Now maybe that's not where Venus is, and then it's not an evening star. You notice it could be closer to the sun and be an evening star, and it would look bigger through a telescope and it'd be a bit brighter, or it could be farther away from the sun, it would look dimmer and smaller through a telescope. But if it's a morning star, it wouldn't be over there. If it's a morning star, you would see it here. Over here is where sunrise is, and so if you're seeing it at sunrise, then it would be, you're seeing it before sunrise. As soon as the sun comes up, you can't see it. So if you're seeing it there, then it has to be over on this side, and it would have to be in this part of the orbit if Venus is seen as a morning star. The same would be true of the inner planet Mercury, the other inner planet, although Mercury is closer to the sun, and so it always sets really soon after the sun, and it rises just before the sun rises.
This animation is showing how the Sun and Venus must set together, and it has Venus in the position of an evening star. On the right-hand side, the dotted line shows the horizon of the yellow triangular observer. Now the Sun sets, but soon after Venus will set. So the only time you'd be able to see Venus is shortly after the Sun sets. The morning star, or Venus, is some people's favorite planet. It could be seen in the morning, you call it the morning star, but it could be seen in the evening, then you'd say it's the evening star. It's only seen near sunrise or sunset. That's also true about Mercury. That's also closer to the sun than Earth is. Neither of those inferior planets, the ones closer to the sun, could be seen at midnight. By the time, long before midnight, they will have set. Venus is sometimes, well, no, Venus is the brightest object in the sky, unless the moon is up or the sun is up. Here's a quick view looking east with the orbit of Venus and Mercury sketched out, so you can see the sun is below the horizon, and those planets are as far out as they would get. That we call that position greatest elongation. This diagram shows opposition and conjunction, and we talk about opposition in this class. It simply means the planet is on the opposite side of Earth from the sun. And you should be able to see from this that the planet would be up highest on the midnight side of the Earth, and you would be able to see it on the nighttime side of the Earth. Whereas at conjunction, that object would be right near the sun. But we've mentioned opposition because when a planet is undergoing retrograde motion, it's near opposition. Here's an example of the Sun, the Earth, and Mars, so that would be Mars in opposition. And you could lay it out like on the bottom, or you could lay it out opposite of that. Either way, That's opposition, when the planet is opposite in the sky from the sun. So how often will a planet be in opposition? And one hint is that the outer planets are the only ones that are ever in opposition. The inner planets actually move faster. And before I answer that, look at the picture to the left. This is the one I used for that challenge question. That dotted line in the background, I said, what would that be? In the foreground, that bright object is Mars once a night, seeing it in retrograde motion. And there's something moving in the background, and it is near the ecliptic because Mars is in the ecliptic. And it's moving compared to the background stars. It must be a planet. And it turns out that's Uranus. So how often will a planet be in opposition? Well, if the planet wasn't orbiting around the sun, it would be once a year, because every time we came back to that position, the planet will be in opposition. However, because the planets are moving more slowly than Earth, because Earth is closer to the sun, because the planets are moving, it takes longer than a year before they're in opposition again. For the really far out planets, it's almost a year. But Mars, we have a heck of a time catching up to it, and it's more like 2 years from Mars being in opposition to the next time. I hope you have a chance to actually look at the nighttime sky. Here's a couple ideas to help make that more profitable. One thing is, if you're looking at a faint extended object, try looking not directly at it. That's called using averted vision, especially if you have a chance to look through a telescope at a fuzzy dim object. Look sort of near it, but concentrate on the thing you're interested in. Another thing is, especially if you're ever at a star party, take a dim red flashlight. Red light allows your eyes to recover more easily to the dark, and you want to give your eyes time to adjust to the darkness. So light in general is bad, but if you needed light, it's best to have a red light. And if you're at a star party with amateur astronomers, they will snipe at you if you are using white light. They'll yell at you from across the field, trust me. So if you were looking at things in the sky, remember you could see planets. The only ones you could see would be Mercury and Venus, Mars, Saturn, and Jupiter. Keep in mind you only see them because they're reflecting sunlight. And you might be able to see star clusters, the Pleiades, that's the Seven Sisters, and the Hyades, which is right near it, and M13 is a globular cluster that supposedly you can see with the naked eye if you're in a dark sky with your eyes dark adapted. There's a galaxy you can see in the northern hemisphere, the Andromeda Galaxy, known as M31, and that you could see without a telescope or binoculars. Well, just barely, but you can. There's Double Star, Mizar and Alcor, the kink in the handle of the Big Dipper, and then there's various constellations, and that's what we'll talk about in the next sub-module. So in summary, for this module, you've gotten kind of a somewhat disjointed introduction to the sky and astronomy in general, talking about what is the ecliptic, where the planets are seen in the sky, that there's retrograde motion that you can observe without a telescope, what is opposition, things like that that we're going to build on in the coming units.